Well, all right. Well, now we get to use our skills to solve equations using properties of logarithms. So we got here 2 log 7 of x equals log base 7 of 27 plus log base 7 of 3. Well, now if the product property, the power property, would allow us to rewrite this on the left as the log of 7x squared equals, and then here on the right we can use the product property as the log of base 7 of 27 times 3. And let's see, the log, I'm going to do this with several steps. Shortcut, I would shortcut this if I was doing it myself. So we got log of 7, base 7 of x squared equals log base 7 of 27 times 3. 3 times 7 is 21, that's 1, carry you 2, 3 times 2 is 6, 8, 81. 81. All right, now, technically speaking, and we could have done this up here, all these log 7s are going to cancel. And so then we can be left with x squared equals 81. So then therefore x is going to equal, and I'm going to say, technically speaking, I could say plus or minus the square root of 81. And so x equals, well, the square root of 81 is 9. Now, one thing we cannot do is take the log of a negative number. And if we were to try to use negative 9 here in this plus or minus square root of 81, well, right here we would be taking the log of a negative number if we substituted in negative 9 for x. And so the correct answer is x is equal to 9. Okay, well, that wasn't too bad. Shall we look at another? I think we shall. Okay, so in this one we got log base 6 of x plus log base 6 of x plus 5, that's in parentheses, equals 2. Well, so I'm going to go ahead and rewrite this. I'm going to apply the product property. We got log base 6 of x times x plus 5. Well, that's not too bad. But what are we going to do with this 2 over here? We don't have a log base 6. Well, that is simply going to be 6 raised to the power of 2, or 6 squared. Remember, logarithms and exponentials are inverses of each other. And so now this will allow us, we can cancel this log 6, and we've got x plus 5 equals, well, let's see, 6 squared is 36. Now let's distribute the x to the x plus 5. That gives us x squared plus 5x equals 36. And we're going to subtract 36 from both sides. Set this equation equal to 0. X squared plus 5x minus 36 equals to 0. And we're going to factor this quadratic equation. And then set each factor equal to 0 and see if we've got a valid answer. Let's see, we got x. Our middle term is positive, our last term is negative. And so I think, let's see, I need two factors, two numbers that are going to multiply to negative 36 and add to plus 9. And I think if I go, plus 5, excuse me, x plus 9, x minus 4. 9 times negative 4 is negative 36. 9x minus 4x is 5x. All right, let's set each factor equal to 0. So we got x plus 9 equals 0. X is equal to negative 9. Now, we just discussed that we cannot take the log of a negative number, and if I substituted in negative 9, for x, I'd be taking the log of a negative number, so that is not a valid solution. Let's check our other factor. X minus 4 equals 0 when x is equal to 4. All right, so let's see. Let's go back and prove this thing. This is our answer. X is equal to 4. But let's see what we do if we go in here and prove this. And I'm going to go right back. When we got to right here, this step right here. Okay, log 6. No, I don't want to use that. Let's use this step right here. So we've got 4 times 4 plus 5 equals 36. Well, 4 plus 5 is 9. I've substituted in 4 for x right here and x right here. 4 times 9 equals 36, and 36 does in fact equal 36. All right, cool. We are done.